The Midlands region is delighted to host this evening's webinar on PFAS, poly and perfluoroalkyl substances, and I would like to thank the Chemical and Process Engineering Division and the Water and Environmental Society for their support. In recent years, the acronym PFAS has, as well as the moniker Forever Chemicals, has entered into common parlance. In this presentation, Bill Atkinson will explore why and look at the main concerns that have suddenly emerged around these chemicals, explaining more about their background, how they have been used, where they may present a problem, and how regulators are responding to the challenges that they pose. Bill is the Chief Scientific Advisor at Adler and Allen, leading a team that provides 24/7 emergency chemical incident advice worldwide, allied to chemical incident response in the UK. He heads up the Pollutants Advisory Group, PAG, at Adler and Allen, which brings together the group's various technical and practical experts in pollution management. The PAG was formed in response to the challenges presented by a number of large projects that the group was undertaking. Bill's role is to coordinate the activities of the PAG and help the Adler and Allen group to apply the lessons learned from incidents more widely and to the benefit of their clients. So Bill, I'll hand over to you now to begin. Thank you.
Thank you. Thank you, Alan. Good evening, everyone. And it's a particular pleasure to be introduced by Alan. He's a former colleague of mine, so with him, for whom I have fond memories. So yes, as he explains now, he calls them PFAS and I call them PFAS. So I suppose we had to call the whole thing off, really. So goodbye. No. It's the acronym we'll explain, and just to kind of go through what they actually are. So but before I get into the meat of it, my colleague Jonathan Devine's also on the call. JD, did you want to say anything at this point to offer an introduction?
Yeah, no, thanks, Bill. Thanks for passing me on. Sorry, I was a bit slow at connecting there. The Wi-Fi was letting me down. My name is Jonathan Devine. I'm the Consultancy Relationship Manager here at Adler and Allen, both the UK and Ireland, working alongside Bill and the wider Adler and Allen team through their many divisions that we had. So we're one of the things we're tackling right now across the area is the PFAS or PFAS, as we're getting into there. We're not going to split it. And I'm sitting on this call just to introduce ourselves and answer alongside Bill any questions towards the end. And looking forward to this presentation.
Okay, thank you. Thanks, JD.
Thanks, Bill. Cheers. Thanks.
Okay, cool. All right, so this is what I tend to try and cover this evening. So Alan's briefly introduced the role about the organisation and this Pollutants Advisory Group. I'm going to talk very, very briefly about some of the work we've been doing and how that feeds into certain pollutants that we are particularly concerned about, certain persistent organic pollutants, or POPs, as they are known. There's loads of acronyms here. You might have picked up on these, like PFAS, POPs, etc., endocrine disruptors. So we'll talk a bit, obviously the topic du jour is very much about PFAS. So we'll talk about that and the various aspects they're listed, really, and again, as per the introduction. A little bit about firefighting foam in there, because I'm trying to think about how practically some of these aspects and topics might affect you. So we'll go through that, and I'll just kind of reference a couple of case studies that we're currently working on, really, without thinking before going into conclusions in the kind of future, really. But very, very quickly, who are Adler and Allen? So it's a company that has been in business for 99 years. Currently, it is it's certainly expanding enormously. When I joined, there was about 1,800 people, I think, and sorry, it's now 1,800 people, and it used to be about a few hundred. We cover a very wide range of services to do with environmental risk reduction, and that includes both consultancy and implementing solutions. And I think that makes us unusual. There are a number of consultancies who will offer advice, and there are people who come along and put kits on the ground for you, and we actually do both. And the organization is split into three parts. There's an environmental division that I work in and JD works in, and then we have a water and ecology division, and we have an energy division. which includes both historic hydrocarbons and also electric vehicles and so on. So Alan mentioned in the introduction, this group are kind of set up. It's a virtual group within the organization, and it's trying to ally, and kind of a little bit like the company, ally the advice that we can give, the technical advice, and the implementation of practical solutions. So people who can actually make the kit work. So we work out the theory, they make it happen. And so it brings together that kind of expertise. And we've had a couple of juicy projects to work on, one of which I'm not going to talk about tonight, but for those of you who might have heard about the fire that happened at Luton Airport, they call it London Luton, but let's face it, if you know anything about England, Luton's nowhere near London. But anyway, Luton Airport, and there was a big fire there which caused big pollution incident, and we were involved quite extensively in trying to deal with that, and to a very successful conclusion. And Luton are very happy for us to talk about that. So that's a site I can reference. So that group really kind of came to its own during that kind of incident, really. And so myself and my team were kind of involved in things like understanding the chemistry of what was going on there, looking at the lab results, interpreting the lab results, and all that kind of thing, really. But one of the other things the group does is look for hot topics, and PFAS very definitely fits into that. And we were kind of on it before it's become a little more fashionable and people becoming aware of it now. So with that in mind, I kind of wrote a position piece last year, which is very much due for an update. So I would heavily caveat this to say that, yes, you can download it and it may still be worth your while to do that. But it is currently in the process of being updated, because while this guide covers the topics of PFAS and also things like runoff from metal fires, from lithium-ion battery fires, etc., endocrine disruptors and nanomaterials, PFAS probably was about 70% of that guide, and it's the area that's changing the fastest. So that's the area I'm going to concentrate on for the update this year. But it was designed for both the clients of Adler & Allen, or prospective clients, and also to be used as an educational tool internally and externally. And there are kind of lighter versions, and then the fuller one as well, which it goes into a bit more depth about some of the things I'm going to talk about tonight, like the chemistry and the science of it, and also reference sources that you can look for further information as well. But get onto before I get onto PFAS in the main, I'm going to talk about POPs in general, because some PFAS molecules, and I should explain what PFAS is. I haven't done that for anyone who doesn't understand what it is. It's per and polyfluorinated alkyl substances. So effectively, they are fluorinated hydrocarbons. But anyway, we'll explain a bit more about the chemistry, give you PTSD from the science lessons for those of you who are not chemists. So some PFASs are also considered to be POPs, but POPs have this property that they tend to be attracted to oil or fats, lipids, and they can therefore, when they get into the food chain, can accumulate because they get stored within the fat cells of the living organisms. And as they go up the food chain, the accumulation within each species increases. There's a very famous example of DDT, which was a very effective pesticide used to kill mosquitoes. And then, of course, the fish ate the dead flies, then the birds ate the fish, and they accumulated and ultimately ended up being poisoned by DDT because it just didn't break down, it persisted, and it bioaccumulated as it goes through the food chain. And actually PFAS, when we come onto it, there are many PFASs that do that. So, but the world of POPs is much wider than PFAS. Same is also true of endocrine disruptors. So the endocrine system is the regulating system of the body. It's the messenger system of the body, and it utilizes hormones, signaling molecules. And it does that, obviously, there's a whole plethora of pathways. And endocrine disruptors can block those. Either they can mimic things that are naturally present, so things like your hormones, and you've heard about things like estrogen molecules that mimic estrogen and cause health effects that way, or they can stop the regular hormones from being able to work. And again, there are some examples there. Your You might have come across things like phthalates, used in things like certain cosmetic products, bisphenol A, BPA, which was found in things like children's toys and so on. And then dioxins, which are produced from things like low temperature fires and so on. And parabens, again, also used in some cosmetic products. They each have to have a pathway for this to work in the body. But yeah, so those are two acronyms to bear in mind when we're dealing with PFAS, because some of the properties of some PFAS have these kind of properties, if you like. So I've explained the acronym PFAS, but and we'll come on to the structure. I'll talk a little bit about the structure, but because of the structure of that molecule or the group of molecules, and I should say at this point, there is no one single agreed definition of what PFAS is. And that's for a number of good reasons, because I think everybody agrees that you've got this presence of fluorine, certainly, bonded to carbon, which fundamentally gives it its properties. And I know there are a number of chemists on the webinar tonight, so they'll understand about the strength of the carbon fluorine bond, and that is what gives it its persistence. It doesn't get broken down very easily, which makes it ideal for things like use in certain surfactants that persist. So if you want a foam that you can put onto a very intense fire, certainly particularly something like a flammable liquid fire, it works extremely well. Of course, then when you've done that, it persists in the environment, and that's where the problems come in. But this properties of the molecule being able to occupy this kind of space between phases and so on means it's really good as a waterproofer, and then that means it can be used in a whole range of things like food packaging, in pharmaceutical products. It can be used in food packaging, non-stick pans, hence why the original topic, because hence the non-sticking around. For those of you who know me, I love a pun. So the whole plethora of applications which can impact on our professional and our daily lives. But in terms of the structure of the molecule, all PFASs have this kind of, certainly surfactant PFASs have this kind of property. So it's a moiety. So this is like it's a molecule of two parts, if you like. You've got a fluorinated, either fully or partially fluorinated hydrophobic tail that doesn't like water, and then you've got a functional group on the top which does like water, and that can be something typically like a carboxylates group, or it can be sulfonates or betanes or phosphates and so on. And so you've got that combination of properties there, of both hydrophobic and hydrophilic, and it means that it makes a really good surfactant, and the strength of the bond and the effects that has on the rest of the molecule means it's really stable, and it tends to persist in the environment. So it does get this moniker of this, kind of, it's a term I'll discuss forever chemical, but it does get that moniker for that reason, really. Should also explain there's further detail around the descriptors around PFAS. We tend to talk about short and longer chains, and that refers to the length of the fluorinated chain. So a lot of the common firefighting foams, for example, that are used now are what we call C6 foams, but you still got 8 carbon atoms on that tail, but only 6 of them are fluorinated. And it gives it slightly different properties to some of the older traditional longer chain foam, longer chain PFASs, so like PFOS, P4, like I said, acronym soup here, that were fully fluorinated. In terms of trying to describe these molecules, as the organic chemists will know, the nomenclature gets extremely complicated. So sometimes a shorter way of referring to these is to use these acronyms, these shortened abbreviations, if you like, or to use something like CAS numbers, which are in a standard format, can be used to describe that molecule and to search for it as well. But yeah, so you get short and long term, and typically there is a feeling that the shorter chain PFASs are less problematical than the longer chain. It ain't necessarily so, I'm afraid. So there are issues around the shorter chain ones. So there is emerging research to say that there may be some effects in terms of, for example, crossing the blood-brain barrier for some of the short chain ones, and they still have this issue of still got the fluorinated tail that doesn't break down. There were next generation, so generation X they're called, that were PFAS introduced in America, also found to be causing problems, or you find some shorter chains that can actually join together and create longer problematical materials. So it isn't true that shorter chain is necessarily better than longer chain. It's just that there's more health effects that are proven for the longer chain ones, so the fully fluorinated 8C8s. So yeah, that moniker Forever Chemicals, it is controversial, and one of the reasons it's controversial, it's not technically true. However, for the reasons I've described around the carbon-fluorine bond and the persistence of it and the strength of it, then it does mean that these things kick around for a very long time. But you do get metabolism within PFAS molecules, so you will get some changes in there, and there are, you know, pretty allude to at the end, some technologies have been looked into to try and break them down. So it is true that PFASs that have been already released into the environment tend to kick around for a very long time, certainly multi-generational. And I talked already about the bioaccumulative effects in plants and animals and so on. So, and then of course, there's potential for some of them to interfere with the endocrinal system within organisms. So this is what's led to the concern, and there's been a slew of articles around PFAS. So the Guardian did a whole series of articles on PFAS recently, and that included stories on the town of Bentham in North Yorkshire that was host to a firefighting foam company, Angus Fire, and they found very high levels of PFAS within certain soils around there, and obviously said emerging evidence around the effects on the body from exposure to certain PFAS molecules as well. So yeah, that's kind of leading to some of the increasing publicity around PFAS, if you like, and probably is one of the factors that's led to me being invited to speak to you tonight, really. The concerns are not just being raised by pressure groups or NGOs, it's also starting to get the attention of the investors, of regulators, obviously, which we'll come on to, but certainly anyone doing kind of due diligence from any kind of purchasing, and that includes purchasing of land, for example, may well be asked by the purchases or the finances of that deal, or even the insurance companies, which we'll talk about next, whether there has been any investigation of potential problems of PFAS contamination on the sites, because it may not be apparent. So it's starting to get scrutiny from a lot of different sources. And said that includes insurance companies. And one of the reasons for that is because of the settlements that have happened in the US in particular. So the manufacturers, 3M and DuPont, have obviously had to settle for very large sums, in some cases, for some of the contaminations that they've caused, some of which has found its way into popular literature and so on. But there have been others as well. And I think there is a feeling that there's concern that more of that is in the pipeline. And there are still lawsuits that are currently working their way through courts in the US. And that certainly will concentrate minds and could lead to increased regulatory action or pressure, even irrespective of whether the regulators, the government regulators, actually will continue to go down the route of increasing restriction, certainly in the US, and what's happening there. So obviously, PFAS is produced from manufacturing processes. How do they spread around? Well, we know they persist. We know that. So they can come from manufacturing processes. They can find their way into the air. They start to then go into things like rain clouds. So we actually do detect PFAS within rainwater. So one of the sites I'm coming on to talk about later, we were finding levels that were surprising us in places. So we actually analysed things like the concepts of the downspouts of the surface water from the buildings, and we're finding it in there. And then another site we're working on, the Environment Agency were asking for levels of one particular PFAS to be at very low levels. And I asked the samplers just to sample upstream of the site, and we were finding it in the upstream of the site at higher levels than the Environment Agency were insisting on the discharge was set at. So it's just to show it's coming ubiquitous. And I've got some maps to kind of really scare you in a second. So it gets into things like rainwater, groundwater, and then gets into us basically. So in terms of the surveys of contamination, now bearing in mind, this is just the points that have been measured, and the sample points tend to coalesce around centers of population, because it will come from things like industrial activity, from use of firefighting, either as a training exercise or for putting out fires. So things like locations of military establishments, airports, and so on, so fire stations. I mean, firefighting foam is not the totality of the problem, but it's been a large source of it. And there was a whistleblower case in 3M. So there's a lady who basically was carrying out blood tests on the workers at 3M and found that they had virtually everybody had PFAS in the blood. But then, they work at 3M, maybe that's to be expected. So she went out to the local population and found high levels of some of the same PFAS molecules, particularly like PFOS, some of the older C8s, in the bloodstream of the population. And they're thinking, well, this has to be an error, surely. Is the analytical equipment going wrong? And they had to go back to tests from rural China in the 1980s to actually find blood samples for people with no evidence of PFAS in the bloodstream. So emphasizing this issue about bioaccumulation and persistence, it's once it gets into the bloodstream, it tends to stay there for a long time. And a similar picture within Western Europe. So again, tending to follow centers of population where we're measuring it. And the EA has done, the Environment Agency, England, Wales, and so on. And I'm sure the same is true in Ireland, that it has been found. So again, you're probably going to ask, for those of you in the north, oh, well, we're fine, we're grand, there's nothing spotted in the north there, only one point in the south. Like I said, this is a snapshot, and these were only of sample points that were taken at that point. I think it would be naive to suggest that you don't have a PFAS problem, because everybody does. Where you have population and you have activity, you have a PFAS problem. So I've alluded to some of the health effects from PFAS. So some of the specifics here about health effects and how they're related to specific compounds, and mainly we have a lot of data on some of the older C8s. So PFOA, PFOS, PFH, XS, even the acronyms are not easy to say. They tend to be the one that we have more data on because they have been around a lot longer. So we notice things like elevated cholesterol levels are noted within people who've got, again, association, causation, but we tend to start to see some effects, some proven effects as to why they may be responsible on a physiological level. So lower antibody response to vaccines, changes in liver enzymes, pregnancy-induced hypertension and preeclampsia, differences in birth weight and so on. And then in particular, certain cancers. And there have been instances of firefighters that have had certain more prevalent and more prone to certain cancers, like testicular cancer, kidney cancers, and so on, that may be related to having PFAS within the body and in urine and things like that, and even exposure to firefighting equipment that also uses as a waterproofer. So how do you get exposed from PFAS? So you've seen how it spreads in the environment. Where can we potentially get it from? And it can be directly from consuming food and drink. So we know it likes, it's a surfactant, so we know we can get it. It actually goes directly into food, either from the water, then putting it into the food, or directly from the water. And it kind of comes ultimately from those sources I mentioned before, like releases from industry, releases from firefighting foam that affects surface waters and so on. And of course, it can accumulate in things like milks and so on, and breast milk, and it's been proven basically to accumulate in that way. Okay, so now we go on to some specifics and talk a little bit about firefighting foam, because I think even if you think, oh, it's not going to affect me, well, one of the case studies I'm going to highlight is a site that the fire service came and turned up and basically applied foam to their site and put a fire out. And they had flammable liquids on site, so hence why they use firefighting foam on that. And they had to deal with the consequences of that and the contamination that was caused from the use of that firefighting foam. And for those of you who might have heard about, there was obviously the fire that affected Heathrow Airport from the electrical station nearby. That's another incident we're currently involved with. So we're looking at the options for the waters that were used from the runoff from fighting that fire. So firefighting foam, everybody tends to think of foam as the same thing, and it's actually not. There are different types of foam. So there are fluorinated and there are non-fluorinated foams. And if you are planning a site or planning a refurb of a site, it's probably worth finding out which one you have. One of the cases I'm going to mention, they have quite a new site. They specified a firefighting system within that and didn't know it contained a fluorinated foam until that system was accidentally discharged. And at that point, they realized that it was a fluorinated foam. And there are, I would say with very, very few exceptions, is there a requirement for fluorinated foams now, really. So we're starting to see kind of phasing out of even the C6s or the short chain foams now, but they are still available on the market. You can still procure them, you can still buy them. If you're not sure as to what type you actually have, and that includes the portable extinguishers, because of course you can cause contamination with the portable extinguishers, then the only way really to check is to ask the supplier. Even checking the safety data sheet that may come with that foam is not a guarantee, because most PFASs, while there are issues around them, as we can see from chronic exposure to them, do not meet the criteria for being declared hazardous on the safety data sheet. And I speak as certainly in the past, an STS author, so understand about the classification criteria. So you cannot just take it from the STS. You would have to get that information from the supplier of the foam. So I mentioned two main types, fluorinated, non-fluorinated, and even within the fluorinated, you've got the older P4 foams, which are being phased out, and then you've got the fluorotenomers, which are seen to be the newer generation. But some of the protein foams that are now available are very good. You can even get ones. They tended to be in the past, for the physicists in here, they tended to be non-Newtonian in terms of the fluid properties, but now you can actually get Newtonian ones as well. So things have moved on a lot in terms of non-fluorinated foams, and some very good products out there now that are available as alternatives. So going within the specifics of fluorinated foams, PFAS foams have been banned from a long time now. I can still remember the 2005 Buncefield fire when a lot of PFOS foam was used on that fire, and it's caused long-lasting problems there. The aquifers around that site have been contaminated probably forever now. P4, the perfluorooctanoic acid, can still be used in certain circumstances for a few more months. So where the fire waters can be contained, it can still be used, even though it's been removed from general circulation. Existing stocks can still be used until the sunset clause runs out on the 4th of July. And then we've also got PFH XA, which again is starting to get a lot more restrictions, and we're expecting it to go down the route at the same kind of levels of restrictions as P4. UK is kind of, and I say UK is lagging behind. So the UK obviously will include the North. For those of you in the South, you are bound by the EU, of course, and so the restrictions are moving at a faster pace there, really. So within the UK itself, there is a consultation that was placed on firefighting foam that happened last year, recommended further restrictions. There is a bit of a toing and froing. I'm kind of giving you the insight from this side of the Irish Sea, but I'll come on to some of the restrictions that are being proposed for the EU, which affects you more on your side of the North Sea, really. But as I say, so there's increasing restrictions on which activities can also be used. You can't use firefighting foams, fluorinated foams for training anymore either. Now, PFAS is not the only consideration when you say what you're considering foam. So there are lots of other properties that do affect the environment if they're released. So the two big ones are really kind of BOD and COD. So biological oxygen demand, effects on the organisms, and the DO, the devolved oxygen in the Watt's column, and the chemical oxygen demand that again affects the DO. And that can have effects on the toxicity at different trophic levels, so from algae through to invertebrates and then to high species of fish and so on. And you still have to look out for these issues, the PBTs, we call them, the persistence, the bioaccumulation and toxicity. Because if any of these foams still do contain persistent organic pollutants, then they could still have some of these effects. This is what a safety data sheet will now tell you, this information. So since the last REACH updates in 2022, any PBT ingredients have to be declared in section 2 of the safety data sheet. So that would, if the SGS is up to date, will give you that information. So in terms of, if you're procuring foam, what's the best choice? I mean, the first point to say is it's got to actually work at what it does. So depending on the class of fire you're dealing with, so, it's got to work. But know that there are problems with pollution from all foams. And in the past, I used to roll my eyes, even quite visibly, when you get salespeople from firefighting foam agents saying, "Oh, this is environmentally friendly foam." There is no such thing. It's just how bad the damage is, really. So, but I would say that heavily recommendation is to avoid fluorinated foams unless you absolutely have no alternative, and there are very few of those these days. Okay, I'm going to talk a little bit about the technology around dealing with PFAS as a problem. So, and I'm going to concentrate mainly on waters. So, because that has been our predominant experience so far, we are dealing with some sites that have ground contamination. And in that situation, you're looking at options around stabilization or maybe using waters to remove PFAS because of other problems associated with trying to remove large volumes of soils and other, substrata, that kind of thing, really. So, yeah, so there are a whole range of methods that we would normally use for contaminants, particularly hydrocarbon, which of course is the history of Adler & Allen and the OHS consultancy on which I work. And so, we would use things like surfactants and so on, and basic chemical techniques and that kind of thing. None of these work with PFAS, unfortunately, because of that, the nature of the material, it just doesn't break down. So a lot of those traditional methods, including water treatment works, of course, the methods used in water treatment works will not remove PFAS. So you have to look at certain other technologies to look at that. Now, when we're dealing with foam concentrates in particular, we will often consider whether it is worthwhile to use foam fractionation to try and concentrate the problem and make it cheaper and easier to dispose of the PFAS within that. And when we do that, we're exploiting the properties of the surfactant. So some of you might be familiar with how surfactants works, and I'm trying to allude to that. You're looking in that interface between the phases, so between air and liquid and so on. And you can use foam fractionation by passing air and also using interionic interactions to try and increase the population of the surfactant molecules within each bubble. So you're then taking more of it out and then concentrating that into fomate, which you'll then send for either treatment or for destruction, really. And that can be helpful because one of the problems, certainly, I don't know what the disposal situation is like within the island of Ireland, but within the I'll call it the mainland, or certainly the British Isles or the British island, we only have two main disposal points for high temperature incineration, and there is a lack of capacity at both, not least because the rate at which it can be introduced to the incineration process is limited. So that is a severely limiting effect. So the other technologies we're kind of using at the moment, some of the main ones that exist, ion exchange, granular activated carbon, which has to be configured for PFAS, it has to be said. So the GAC or GAC that we're currently using is specifically designed for that process. And I'll talk about this within the case studies in which we're currently dealing with. There are others as well. So things like reverse osmosis is effective, and so on. So other technologies that can be used there. But as I said, for ground, more limited, you're either looking at pump removal using waters to treat the waters, or you're looking at stabilizing it. You can't actually destroy it in situ in the same way you can with the hydrocarbon spill. So it is really about trying to stop the spread of this thing. And there are a whole range of products out there that will work in a similar way, and they all tend to be based on things like activated carbon. So it's just a lot of similar kind of stuff that we're using in the filtration methods. Now, in terms of restrictions, so environmental limits on waters, we've had European restrictions in place since 2021, setting the limit at 0.5 microgram per litre for any PFAS molecule. Within the UK, we have 1 EQS for PFOS, and there's kind of certain new levels been suggested for EU as well, which affects the say, Republic of Ireland and North as well. We have drinking water standards over here as well. Now, the US is an interesting one because the EPA over there proposed some extremely tight standards, proposed going down to 4 parts per trillion for some PFAS molecules. Now that has been chucked out with the new administration. However, it's not the complete story. So there are still federal bills that are being debated at the moment, and certainly some state laws that are likely to be introduced. So there's still quite a lot going on with PFAS in the US. In terms of the UK itself, which would say will affect the North, PFAS is part of the Rolling Action Programme, which is a bit like the COBRA in the EU, which again has got some PFAS activity within that. And there's this kind of management options paper that was produced by the HSE, and of which we're currently waiting updates on, really. So it's much slower than what's happening in the EU at the moment. So there's a lot more happening within the EU. So ECHA has 2 committees that are looking at the whole issue of PFAS. So you've got the Scientific Committee for Risk Assessment, and you've also got a separate Socioeconomic Analysis Committee, and they're going through the use of PFAS by sector. And there's a whole range of sectors there. I'm not going to read them all out, but you can kind of see those and refer back to them. They do publish regular status updates on the ECHA website, and you can find the links. Hopefully you'll get a PDF at the end, and hoping that link will work within that. If not, I'm pretty sure I had a link in the white paper, and we can provide that anyway. So there's a lot going on there, a lot of dates that each committee is expected to report by, and some of those reports have been produced, but there is fair to say a fairly wide ban proposed on the use of PFAS within the EU. Not total, but quite wide ranging. So I've mentioned about case studies, just to kind of finish off. So we're currently using GAC to try and remove it from a couple of sites. And so one of them was a site in England, which I cannot name, unfortunately, but had firefighting foam applied during a serious fire, contaminated the site interceptors, drainage system, and so on. And we had not only that problem, but also the problem of we couldn't discharge anything to surface waters from that site. So all the rainwaters that have been produced on that site had to be stored and dealt with. And this included the winter of 2023 going to 24. And if you remember back that far, I'm sure it's the same in your side of the North Sea, but it absolutely bucketed it down, and we had a lot of rainwater. So there were huge quantities that we had to try and deal with, and a lot of it had to be held in these kind of temporary storage tanks here. There's quite large storage tanks, and then we had to try and devise a treatment system to try and deal with it. So it was put through a sequence of almost like, filtration units, each housing this GAC. And it had to be tweaked and configured quite a lot. But we ultimately managed to get it down to the stage where we got permission to discharge to surface water. And the water that was coming out of these was cleaner than the background environment in terms of the PFAS content. Now, the position has moved on, I would have to say, but whether we get permission to do that now, I'm not entirely sure. This is the second site we're working on. And this kind of does illustrate how the EA position, certainly in England, is changing. So initially, they were really kind of receptive to us treating it and releasing it, and then kind of had a change of mind. The situation here is that we did treat the waters, but rather than discharge to surface waters, we were unable to get a tanker. We had to tanker it away, but we were able to dispose of it at quite a relatively reasonable rate. So we brought down the cost of direct disposal and also provided a disposal pathway where one may not have been available, really, if you like. So some of the insights I can kind of give you from doing these, really. So PFAS is a contaminant, but you still have to kind of make a lot of the same considerations as you would for other contamination issues. You have to understand the site you're working at. You need to try and establish clear objectives. And of course, that has to be done in consultation with the regulators that, whether it's in the north or south, you would have to get their agreement and work with them. Getting good data, understanding your monitoring points, making sure that you get data to characterize your site and understand the problem. And then, of course, you can design the solution around that data. We can't, when we're looking to planning these things, if we don't have that good data, it really is kind of a lot tricky. Things will never go exactly to plan. We've had many, many bumps in the road in trying to get where we've got to with those two case studies, believe you me. And, planning for things like emergencies, like heavy rainfall over a bank holiday weekend or a Christmas holiday, So some of those are real issues that you can find in trying to deal with these issues. So put source pathway receptor, think about where it's going to go. Even like I said, it's just like any other contaminant, even though this is, it is a kind of another contaminant, if you like. If you're planning to swap over fluorinated foams to non-fluorinated, do not think you can just do a quick retrofit. You will have to probably remove the vast majority of that system, because PFAS just clings to surfaces, whether it's pipe work, and in particular, we're finding things like concrete. It really does absolutely weld itself to that, or sediments. It loves the sediment, and it can leach back out again. So you're treating waters, and then suddenly you're getting a spike of recontamination. So this can be a problem, and of course, you're dealing with the problem of, like I said, rainwater and large volumes and so on and so forth. Maybe background pollution from other activities or other sites. All of these are things that we have found, really. So, as I said before, establishing your objectives, talking to the regulators, seeing what limits actually do apply, and having good data will help you. It will give you confidence that you're doing the right thing. It will help you to deal with the problems as they arise, and hopefully minimize some of those errors. What I would say about PFAS is you have to get it lab analyzed, and that's not easy or cheap or quick. So some of the turnaround times we're finding on the lab results can be a week, and that can be frustrating. So, and it's incredibly expensive as well. So, but you still do need that good data. There are other analytical techniques that are being developed, and there is something called, top analysis, and some of that can be useful, but ultimately some of these permits and the discharge limits are based on individual compounds, and you have to be able to provide that data. So ultimately, you have to be able to identify individual PFAS compounds or their precursors. or the metabolites. Okay, this just showing the kind of some of the results we actually got from one of those GAC treatment systems, and I was just kind of showing you how it kind of spikes over time, but how ultimately it kind of reduced. So 6,2-FTS is one of the main fluorotelmer compounds, and it's actually a metabolite from one of the main firefighting foam products, FTAB, which can now be analysed for, which couldn't at the time. And you can see how it, and again, you get spikes, so you'll get it coming back out, and that happens over time. But ultimately, you can see the impact of the GAC actually starting to work as it progressed on the project. Okay, and that's showing the levels excluding FTS, because 6,2-FTS was predominant species there. So, and this is showing how the composition changed. So as we remove the 6,2-FTS, we started to get, so the composition, the proportions changed between the two of them, really. And you do get changes in PFAS compounds all the time. Like I said, they're not strictly true that they're forever chemicals. They're just quite persistent. Right. So just to finish up, I realize I'm probably getting short of time, but I'm happy to kick around for questions, even if we do run slightly over. It's the least I can do as a penance for talking too much. So within the UK, let's talk about a chemicals plan. There has been talk about a chemicals plan for years. I'll believe it when I see it, but we'll see. It is likely we're going to get PFAS restrictions, certainly on use in things like firefighting foams. We're starting to see legal actions happening now, threatened in the UK, and starting to become more real. I've mentioned about the US. There's still issues there. The EU, there's loads of restrictions, which I said will definitely impact on certain sectors and so on. And we are starting to look at other destruction technologies. So we are actively talking to 2 technology providers and some universities on other technologies that potentially we can deploy to destroy PFAS in situ. And last but not least, I think growing consumer awareness of PFAS as an issue, what it can do, why it's problematical, and that forcing pressure on manufacturers and retailers and so on to respond to that, really. So yeah, those are my thoughts, if you like. And like I said, those concerns can will I think will only grow, really. So practical advice for you. So consider where you might be using PFAS in your supply chain. If you're on a site, have you tested it? Have you found there's a problem or not? Do you use firefighting foams, or have they been used on your site? If you found a problem or you had a pollution incident, how might that affect your business? How might it affect your reputation, your corporate social responsibility, and so on? So yeah, those are considerations for you, I think, and I'll just kind of leave you with those thoughts. And with that, if anyone has any questions, I'll do my best to answer them. Thank you.
Bill, thanks a million for a very interesting and informative presentation. I'm more than happy to go with PFAS going forward. It'll speed up everything, so thank you for that. I suppose it was just I felt a very comprehensive kind of tour of what the problems, risks, the regulatory approach, and treatment options that are available. I suppose you mentioned it earlier in the presentation about the personal and professional, and you touched on it there again around consumer awareness. And I was just wondering, is there like a database, or where can people find information on, like, was that concept of what contains PFAS, or how much, or what level?
Yeah, no, it's a good question, and I think the area, as I say, as there's been more awareness of it, there has been more pressure for that information to be made available to the public. And even now, there's talk about labeling of products that may contain PFAS. As a good example, I tried to find some dental floss that guaranteed doesn't have PFAS in it, because it's commonly used in dental floss, and it's difficult. There are some links within the white paper for some databases I was aware of when I wrote that last year. And yes, so you can look it up there. Ultimately, you can also go back to individual manufacturers, because that's pretty time consuming because there are an awful lot of products that are potentially affected with it. There are also little practical things you can look at. It just seems like if you've got this cardboard packaging for things like your takeaway food and all that kind of thing, if you put liquid on it and see if it fully beads on there, there's a very good possibility it actually is coated in PFAS. So there's little tells like that you can look at, but yeah, it's tricky. So yes, have a look at the database links in there, but you can ask questions, but it's very, very difficult to actually avoid in everyday life.
Just was it points to the importance of that awareness element going forward. We do have a few questions through the questions and answers channel. So just again, if anyone has any further questions, just pop them in there and we'll pick them up. So Robert asks, in relation to the Heathrow fire, are you suggesting that Heathrow are still using PFAS containing firefighting foam?
London Fire Brigade were. So it was London Fire Brigade that came along and put the fire out on the it was on the transformer station. So it wasn't actually the airport itself. It was a transformer station that was nearby. And London Fire Brigade were the ones that were using fluorinated foams.
Okay.
But yeah, there's quite a lot. I mean, and again, it's potluck as to which fire services still use it. And I don't know for the fire services in Ireland whether they still use fluorinated foams or not. The only way to find out will be to directly ask them. It seems to be there's no consistency.
Okay, thank you. Mick has a question there, just thanks for the presentation, Bill. The ground model example you used indicating a potential pathway to human health risk through groundwater. Is there any research or a risk on potential volatility, vapor risks from PFAS in the groundwater into buildings?
Oh, I see what you mean. So escaping the liquid phase and going into the vapor phase, I would say pretty minimal, actually, because the properties of the molecule, like I said, it loves to sit in this kind of interface between the phases. So actually its most comfortable position, if you like, is in that interface between liquid and air. So it tends, and it's a very low vapor pressure substance. So I would say pretty minimal. You're more likely to get exposure to airborne PFAS from just the air from post rainfall, for example. So when you get atomization naturally happening from rainfall, that's probably a more viable and likely exposure. It's very, very difficult to monitor, by the way, so can't prove it very easily, but that I would say is a more plausible exposure method than from, say, buildings, groundwater into the airspace within buildings.
Okay, thanks, Bill. Mark has a question. Again, thanks for the clear, informative presentation. Are there PFAS contained within building chemicals, for example, admixtures for concrete?
Yes, they are. Yep. Some of them are, absolutely. Is that a problem necessarily? Well, again, so there are a lot of fluorinated compounds that are used in construction materials, and how they could potentially form an exposure risk to you is debatable. And I know there's a lot of pushback on certainly the sector associations currently looking at the EU proposals on restrictions on PFAS are certainly fighting hard on some of these and pointing out that the properties of fluorinated compounds by far outweigh the risks. So it's probably worth having a look at the sector information on ECHA relating to building materials. But yes, they are used in certain building materials and including all certain paints and coatings as well.
Thank you. And Paul has, maybe back to the consumer side, are there PFAS on the coating of the inside of milk cartons?
Can be. Yeah. Again, down to the manufacturer of the foam carton. Yeah, but yeah, it is. So one of the ways that you can waterproof cardboard is by coating it in PFAS, and yes, it can happen. Very, very difficult as a consumer to spot when it is. very difficult, probably nigh on impossible. You would have to go back to, you know, individual packaging manufacturers, and that's not always clear as to who made that carton. So, I mean, I take the viewpoint personally with a lot of these things that, you know, if you can make an active choice, an easy choice to avoid a product that does contain PFAS, then do it. So I mentioned about things like the dental floss. I've mentioned about you know, non-stick cookware, for example. If you've got any old pans that are non-stick, I would probably get rid of them. The newer ones are still a potential risk, but newer coatings, for example, are less prone to break down, and also some of the PFAS individual, because it's not so much the top coating, it's also they use them to actually apply the fully fluorinated polymers on top. So you've got you've got that, and you've also got potentially some breakdown as the coatings start to deteriorate over time. So if you've got older non-stick coatings, I would say something like that is a conscious choice you can make. Whereas if you decide to buy milk, then, well, I suppose you could try and get it from a glass bottle, which I've actually reverted to dairy deliveries. So that's one way you can avoid it, I suppose, buy it in a glass bottle.
Thanks, Bill. We have a few more after coming in. Sarah asked, what kind of approach would you take when liaising with the EA on what is an acceptable remedial limit? For example, are there public exposure limits that are being suggested? Do you have a baseline levels?
That's an excellent question. There are. So the baseline levels that we have suggested to the EA are something called a predicted no effect concentration. And it is defined within the REACH regulations. So it is a calculated limit, and it's based on the ecotoxicological data. And it looks at the different trophic levels of that, and then it basically applies a factor to it. And the way you calculate those is even prescribed within REACH. And we do have some PNECs, to give again the acronym, for individual PFAS molecules. And we did propose limits of discharge at PNEC levels to the EA for one of those two case studies. It was the second one, actually. And that case was accepted, and then it was later withdrawn. So the approach we are trying to take is that we are making suggestions. If I want to give you kind of the advice of dealing with regulators, and I haven't had to deal with the regulators in North of Ireland or the Republic, but the way we tend to work over here is that we kind of have to make a suggestion in a not a fait accompli way, because they are the regulator, but a strong case as to why what we are proposing is going to be the best way forward, and make it quite firmly. And there is also the other problem we're hitting, and again, I don't know if it's true if regulators on your side, is that there are some technical gaps in the knowledge and understanding of PFAS in particular, and it's a real challenge. So yeah, we have suggested the PNEC approach, but it's had, well, not even mixed success. It's just kind of, they have yet to come to an agreed position.
Okay, thanks, Bill. James asks if there are mobile site treatment systems available for treating PFAS in surface or groundwater at source on site. Is Desotec effective?
Yeah. Desotec is one of the ones we've actually used. So we use that on the second one, actually. Yeah, absolutely. And they are mobile units. Both case studies you've seen, there were mobile units that we deployed. So one of those systems is still in place and is likely to be there for some time, just to kind of allow that discharge off site, because it's a much kind of better solution. So yeah, those units, I mean, they do technically count as mobile. They're still quite chunky, but they do technically count as mobile. So yeah. And some of the other applications we're looking at now, there may be some other options in the future, but I think in terms of the here and now, probably the GAC units, like you said, the Tech ones, and others are probably the best way to go at the moment.
Okay. Mark, just in a follow-up to his question about the building chemicals, I suppose the issue will be with concrete washout from manufacturing plants and the discharge water. So
yeah, and that's one potential source actually for manufacturing. Yeah, it's much more significant than the point of use, I would say.
Okay. Christopher, again, thanks, very informative. Points out that an update on your slide showing PFAS contamination across the EU, DCU, Dublin City University are 2 years into an EPA-funded research project. Some very interesting slides were shared recently at the Ireland Brownfield Network Conference. And he mentions Fiona Regan, Lila Bow, and Helen Burke, who are starting to publish some articles in this area. So I'll forward those.
Yeah, please. Thank you. Thank you. I'm very grateful. Thank you.
Connor has a question. Will we see a change on sites going forward on new build water and wastewater plants with respect to systems that activate automatically in the case of a fire around a piece of equipment?
Yeah, I think we may well do, because I think if the restriction on foams is adopted in the EU in particular, I think that will automatically trigger some consequences of that, and that will be from changes to foam use, from replacement of firefighting systems, and there are already kind of automatic shut-off valves that are available on the market that can be better than penstocks. So I'm not endorsing any particular manufacturer, but one example I know of is the toggle block one, which can be triggered as and there are others. And so these can be automatically activated in the event of an alarm, for example, and will isolate things like the off-site discharge. But I think we will see more of that, certainly with the EU restrictions on firefighting foam. Yeah.
Okay, that is all the questions, Bill. So again, thank you very much for your time this evening. A very interesting, informative presentation around PFAS and I suppose the theory behind, and very interestingly the practical application and options that you're working with and developing. I suppose is a very new and a fresh area. So thanks very much. Take care.
No problem. That's fine. My email address is there. At Adrenaline or OHS also works. OHS.co.uk, both work. Yeah, if anybody's got any follow-on questions, or like I said, keep an eye out for potential updates and so on. And again, thanks to the person who suggested those slides on contamination. That's great. That's the kind of thing I'm really looking out for all the time. So thank you. If anybody else has got any other suggestions on reference points or emerging research that they're aware of, again, very happy to accept it. I don't tend to know everything that's going on. It's do my best, but yeah, it's great. Thank you.